Hi, welcome to the third video of the 2018 June Maths Higher Paper 2. We're on question 12. All the previous questions are on some other videos, okay, they'll be in a playlist. So question 12, we've got to find some solutions, okay. Normally you have to factorise and then get a solution, but if you look at our questions here, they've already been factorised, so this should be easy enough. Remember, for all of these we're trying to equal 0, okay, so either the term outside needs to be 0, okay, or the whole bracket needs to be 0. For the whole bracket to be 0, 2x plus 3 must equal 0. Take the 3 to the other side, it becomes minus 3. Then divide by 2, and you get minus 3 over 2. So all you've got to do then is find our list on the right-hand side where the solutions 0 and minus 3 over 2 are. Okay, down to there. For the next one, they're both in brackets. So for the first bracket to equal 0, x would have to be 1. Remember to swap the sign around. And for the second bracket, it would be plus 3 over 2. Okay. So now let's just find where that solution is. 1 and 3 over 2 is up there. Then we've got change the sign, plus 3 over 2, and change the sign to a minus and divide, so minus 3 over 2. So plus 3 over 2 and minus 3 over 2, that's in the middle there, look. And then our last one, it's only one bracket, you don't really have to write this out twice because you're going to get the same answer for both. So same as before then, swap your sign, so it becomes minus 9, and minus 9 divided by 4, okay. And if you wrote two brackets, it would be the same. So there's only one solution. It's minus 9 over 4. Quite a nice question, that one, because you didn't have to do any factorising yourself. Just a little solving bit at the end. Question 13. All of these have been rounded to two significant figures. Okay. So it means that A has been rounded to the nearest sort of unit, whole number. B has been rounded to 1 decimal place, and C has been rounded to 2 decimal places. And we've got to find the least value of D in this formula. So if we want D to be as small as possible, then on the top, we want the numerator overall to be as small as possible. So I need a small a, and I want to take away the biggest B that I can, because that'll give me the smallest overall answer. Okay. And when you're dividing, if you want a small answer, you need to divide by as much as you can. So we'll need to divide down here by a big version of C. Okay, and then you've just got to sort out your upper and lower bounds. So if 26 has been rounded to the nearest whole number, we can go up and down by 0.5. We want a small version of A, so that'll be 26.5. We're going to take away the biggest B that we can. If it's been rounded to the nearest 0.1, we can go up by 0.05. So the biggest that it can be is 1.95. And on the bottom, we were going to divide by the biggest C that we could, because the more we divide by, the smaller the answer is. So 0.81, that's been rounded to the nearest hundredth. We can go up or down by 0.005. We want it to be big, so we're going to go up by 0.005, so 0.815. Okay, all you've got to do then, chuck that into your calculator, and you should get 30.1. Okay. Question 14, arcs and sectors. You need to know your formulas here. They're not given to you in the exam. We are being asked to find the length of the arc. Okay. So that's theta over 360 times 2 pi r. Remember, 2 pi r is your circumference formula, and you just put a fraction in front of it. So that is 191 over 360 times 2 times pi times 3.1. And that comes out as 10.3 centimetres. So that's easy enough. You didn't even have to work backwards. Okay. If it had shown us the other arc, this is sometimes called the major arc because it's the long way round from getting A to B, not the short way round. But that's missing off this diagram. Anyway, so question 14, reasonably straightforward. Okay, question 15. Algebraic fractions. All we've got to do is turn this into one fraction. We haven't got to do any solving or anything like that. Okay. And remember, the method here is to multiply each fraction by the other denominator. So the first fraction, which is 2 over 3x minus 5, gets multiplied by 11x minus 13. And whatever you do to the top, you must do to the bottom. Okay. Our second fraction, and we're taking these away. So we've got 7 over 11x minus 13. And that gets multiplied by the first denominator, which is 3x minus 5, top and bottom. Okay. Now, you don't need to do anything with the bottom. You can leave that in brackets. If we were solving, that'd be different. We'd have to bring it up and expand it all out. But since we're just sort of combining these to one fraction, you can leave the bottom alone, but we will have to expand the tops. So, using normal expanding, we get 22x minus 26 all over 3x minus 5, 11x minus 13. Take away 21x minus 35 all over 3x minus 5. Swap these around so they actually look the same this time. 11x minus 13. Okay, and then on the top, working across your numerators then, so we've got 22x take away 21x, so that leaves you with just x, or 1x. And then we've got minus 26 take away minus 35. So if I actually wrote that out, look, minus 26 take away minus 35, these two would become an add, because they're right next to each other. Minus 26 add 35 is plus 9. So plus 9. And then our denominator, and we're finished then, 3x minus 5, and then 11x minus 13. If we were solving this, you see, if it had an equals something by there, you'd have to bring that up, multiply it all out and do some solving. But we're not doing that. All we were asked to do was to simplify. So we're done. That's question 15. Question 16. Possibly the hardest question on the paper, this one. It is probability, and it's with replacement, which should make it easier, but you don't actually know how many of the beads are red. So that's the awkward thing on this one. What we are told is that the probability of getting 2 reds is 0.1369. We know there are 200 in there altogether, and there are some red ones. Okay. So, probability of getting a red one times the probability of getting a red one, because it's red and red, is 0.1369. And the only thing we can say for sure is that there are 200 in there, and because we're replacing this 200 a second time, we don't know how many reds there are, so you can pick any letter you like. It's not going to change because of the replacement. So n can be the number of reds. Okay, so you've got n in 200 chance of picking a red ball on your first pick, and because you put it back in, you've got exactly the same n over 200 chance on your second pick. Now, if you actually times them together, what you get is n squared over 400 equals 0.1369. Okay. To get n on its own and not squared, so your first job is to bring that 400 up and times by 400, and that'll give you what n squared is. Okay, and then if you square root, you should get 74. So there are 74 red marbles, beads, whatever they are, in the bag. 74 over 200 times 74 over 200 equals 0.1369. So a reverse probability question, not particularly nice, that one. Okay. Okay, question 17. Solving an equation that's a quadratic to 2 decimal places. As soon as they mention 2 decimal places, it's going to be the quadratic formula. But before we get there, we've got some expanding to do. So using FOIL, we should get, so 2x times 3x is 6x squared. 2x times minus 11 is minus 22x. 5 times 3x, both positive, plus 15x. And 5 times minus 11 is minus 55, and that equals 7. Okay, to use the quadratic formula, we've got to do two things. Well, we've got to tidy up the left-hand side, and we've got to move that 7 over because it has to equal 0. So, and that's going to go to a minus 7. So if we tidy all of this up, we've got 6x squared. Those two terms give us minus 7x. We had minus 55 already. If we take away another 7, that's minus 62, and that equals 0. Now we're ready to use the quadratic formula. So there's A, B, and C. You're going to be careful here because we've got minuses. So the formula, which is given to you on the front of the exam, is that one. Okay, putting numbers in then. So minus B, well, if B is minus 7 already, that goes positive, so normal 7. Okay. Then we've got to do B squared, and when B is a minus number and you want to square it, to make that work on the calculator, you'll need to put the minus 7 in a bracket, okay, otherwise you'll get a wrong answer. Then take away 4 times 6 times minus 62. Don't forget about the minus on the 62. All divided by 2a, so that's 2 times 6. Okay, do it once with a plus and once with a minus, and you should get 3.85 for one of your solutions, and minus 2.68 for your other solution. Okay, question 18, we've got to make C the subject of the formula. Okay, so we've got C in two places, so that's not particularly nice, and it's under a square root sign on the left as well. Okay, first job, we're not going to be able to do anything with the left-hand side until we've got rid of that square root sign. So the opposite of square rooting is squaring, so on the other side we're going to have to do some squaring. So GC squared minus V equals C squared. Okay, so effectively that's gone to the other side and done the opposite. Okay. Now we need to get everything with C in on one side and everything that doesn't have a C in on the other side. So what I'm going to do, I'm going to bring that C squared over to the left to be with the GC squared. And I'll take this minus V over to the right because that doesn't have C in it. That's going to give me GC squared minus C squared equals V. Okay. Now we've got to get from having C appearing in two different terms to just C appearing sort of once on its own, or C squared in this case. So we're going to have to factorise. This is what makes this one difficult. They've both got C squared. So if we take C squared outside of a bracket, that would leave us with G minus 1 inside the bracket. That equals V. The bracket is times in on the left, and I want to get rid of it. So I leave C squared on its own. So that's going to go to a divide on the right hand side. So V over G minus 1. You can leave it in brackets, but you don't have to. Okay. And then we've got to square root that, because we want C, not C squared. So C equals the square root of V over G minus 1. Okay. That could be positive or negative. So if you want to be really fussy, you could put a plus or a minus in there to show that there's two square roots, one that's plus and one that's minus. But you don't need to. As long as you've got the square root V over G minus 1, you'll get the marks for that question. And I'll finish off the rest of this paper now. Question 19. I haven't got time in this video, so I'll do question 19 in the video on its own.